Hey guys, welcome back. My name is Amia. In this episode, we're gonna get our hands dirty and get started with Amazon EC2. We're gonna launch an EC2 instance, connect to the EC2 instance remotely, install a web server and deploy a simple web page. Previously we've made this Super Kitty Piano website. We often play it with our cats at Cloudemy. You can go to superkittypiano.com and try it out. Hope by the end of this episode, you'll know how to deploy a website like this onto AWS EC2 in less than 5 minutes. Oh, by the way, let me know if you can guess what song our cat was playing. First, we're gonna launch an EC2 instance from the AWS console. Here are the steps. Step 1, we need to choose an Amazon machine image. We're gonna choose Amazon Linux 2 AMI HVM, which is a public AMI. Step 2, we need to choose an instance type. We're gonna choose a free tier eligible instance type, T2 micro instance. Step 3, we're gonna configure instance details with default values, such as default VPC, subnet, auto-assign public IP, use on-demand instance. Step 4, we're gonna create root volume with EBS volume. Step 5, we're gonna add tags for the instance. Step 6, we need to configure the EC2 security group to allow access via SSH, HTTP, and HTTPS. Okay, I'm on the AWS console. First, let's go to the EC2 service. This is the EC2 dashboard. As you can see, we don't have any instances running. When you create an AWS account, AWS creates a default security group and default VPC and subnet for you, so you can easily launch EC2 instances. You can quickly launch a new instance by clicking this orange Launch Instance button. Or alternatively, go to the Instances page. Let's go to the Instances page. Click the link on the side menu. You can manage EC2 instances on the Instances page, such as Start, Stop, Terminate instances. The instance list is empty at the moment. Please note the EC2 service is a regional service. For example, if you've created an EC2 instance in Asia-Pacific Singapore region, you need to switch to that region to be able to see the instance created there. We're in US East 1 Northern Virginia region right now. We can go to the Singapore region and take a look. We have one instance running in this region. You can only manage EC2 instances in the same region as you created them. Be careful if you accidentally create an instance in a wrong region and switch to a different region, you may end up forgetting the running instance and paying for the unintended bills. We no longer need this instance, so we can go ahead and terminate it. Select the instance and click the Actions button. Under the instance state, click Terminate. It's now terminating. Let's switch back to the US East 1 Northern Virginia region and launch our first instance. Click on the blue button, Launch Instance. It's gonna take us to the Launch Wizard. First, let's choose an Amazon machine image here. Here is a list of all the available AMIs. Each AMI has different set of operating systems, software bundles, such as Amazon Linux AMIs, other versions of Linux, and Microsoft Windows. Some AMIs are built for specific purpose, such as deep learning optimized AMIs were built with common deep learning software packages. You can choose your own AMIs, if you've built your own AMIs before. You can also choose third-party paid AMIs from AWS Marketplace. Click Free Tier Only and you can see all the free public AMIs provided by AWS. We're gonna use Amazon Linux 2 AMI. This AMI is built with AWS Optimized Linux, using HVM virtualization type and SSD volume type. It supports EBS volume as root device type. Each AMI has a unique AMI ID across all AWS regions, which means even two identical AMIs in different regions are different AMIs, with different AMI IDs. We're gonna choose the 64-bit x86 version of the AMI. Click the Select button. Next, we're gonna choose an instance type. Here is a list of available EC2 types. There are 5 instance families: General Purpose, Compute Optimized, Memory Optimized, Accelerated Computing, and storage optimized. The general-purpose T2 micro instance is free tier eligible. It comes with 1 vCPU and 1 GB memory. Let's choose the T2 micro instance. For the instance details, we're going to keep the default values. However, let's have a look at available options. You can choose how many instances to launch at once. You can launch them into an auto-scaling group. We only need 1 instance for now. You can request spot instances and save up to 90%. Check the spot instance option. You can see the current spot prices in this region. The spot price is the price you're going to pay. You can set the maximum price you're willing to pay per instance hour. Your instance will only run when the maximum price is greater than the spot price. We're going to launch the on-demand instance, so we can uncheck the spot instance option. AWS has created a default VPC in a region and a default subnet in each availability zone. The default VPC and subnets have all the components necessary for the internet connection. You can create new VPC and subnets if you have a specific requirement. We're going to launch the instance into the default VPC and subnet. We want AWS to auto-assign the public IP from the public IP address pool. The public IP is associated with the instance until it's stopped or terminated. The new public IP will be assigned after the instance reboots. This public IP is different from Elastic IP. The EIP can be persisted after the instance stops. We need an AWS auto-assign the public IP, so the instance can be reached over the internet. This option is enabled by default when you choose the default VPC and subnet. Optionally, you can launch the instance in a placement group, to benefit from greater redundancy or higher networking throughput, when you have a fleet of EC2 instances. We don't need the placement group. You can reserve capacity for significant savings if your application has stable and predictable workloads, and needs to run for a fixed period. You can launch EC2 Instance into a capacity reservation if they have available capacity and matching attributes, such as instance type, availability zone, and platform. You can assign an IAM role to the EC2 instance, so the instance can assume it and perform certain tasks on AWS resources. For example, if you need the instance to send data to an S3 bucket, you need to assign the IAM role to the instance profile. EC2 uses an instance profile as a container for an IAM role. When you create the IAM role using the console, it creates the instance profile automatically and gives it the same name as the role. You can choose the instance OS level shutdown behavior to stop or terminate. The default shutdown behavior is stop. You can optionally enable hibernate behavior and termination protection. CloudWatch collects and analyzes the instance metrics. By default, the basic monitoring is free, where data is sent every 5 minutes. If you need more granular data, you can pay for the CloudWatch detailed monitoring, where data is available in 1-minute periods. We only need basic monitoring. We can launch EC2 instances onto a multi-tenancy host using shared hardware, or launch instances onto a single tenancy host using dedicated instance or dedicated host. We choose shared hardware for the instance. Keep the other options as default. Under the advanced details, you can configure the EC2 instance metadata and user data. The metadata is information about the instance, such as hostname, events, and security groups. You can use metadata to manage the instance when you connect to the instance. The user data is a configuration script that EC2 instance can run during launch. We're going to come back for user data later in this episode. For now, let's keep the advanced details as default. Next, we're going to add storage. First, we need to configure the root storage device. The root storage device contains all the information necessary to boot the instance. You can set the storage size and choose the EBS volume type. You can choose to delete or persist the volume on termination. If you choose to persist the volume on termination, the volume can then be reattached to a new instance for quick recovery. You can also encrypt the EBS volume for security purposes. Snapshots of the encrypted volume are automatically encrypted. Volume restored from an encrypted snapshot is automatically encrypted. You can add additional volumes. For root volume, you can only choose general purpose SSD, provisioned IOPS SSD, or magnetic standard volume type. For additional volumes, you can choose General Purpose SSD, Provisioned IOPS SSD, Cold HDD, Throughput Optimized HDD, or Magnetic Standard Volume Type. Free tier eligible customers can get up to 30 GB of EBS General Purpose SSD or magnetic storage. We only need the root volume. Let's remove the additional volume. Next, we're gonna add tags. A tag consists of a case-sensitive key-value pair. You can use resource tagging to group resources and manage them in a group. We're gonna set the tag with key equal to name and value equal to Cloudemy web server. A tag with key equal to name is a special tag. It's gonna label the instance on the instance list. We can add another tag key equal to description and value equal to testing EC2 Lab. Optionally, we can apply the tags to both instances and volumes. Let's keep them as default. Finally, we're gonna set the security group for the EC2 instance. A security group is a set of firewall rules that control traffic of the instance. For example, if you want to set up a web server and allow internet traffic to reach your instance, you can add rules that allow unrestricted access to the HTTP and HTTPS ports. Security group rules are permissive and stateless. You can only allow traffic, but not explicitly deny traffic with a security group. You can add multiple security groups to an instance. When you configure the security group, you can either assign an existing security group or create a new security group. The security group rule consists of traffic type, protocol, port range, traffic source, and description. SSH stands for Secure Shell. It's a network protocol for secure access to remote computers over an unsecured network. Later in this episode, we're going to use SSH to connect to the EC2 instance remotely. SSH communicates using port 22. If you set source IP to 0.0.0.0/0, it'll allow traffic from anywhere. As a security best practice, AWS recommends setting the source to known IP addresses. We allow SSH connections from anywhere for now. For the EC2 instance to serve internet traffic as a web server, we need to add 2 more rules to allow HTTP and HTTPS connections. HTTP communicates using port 80, HTTPS communicates using port 443. We're gonna allow traffic from anywhere over the internet. You can review the instance detail before launching the instance. It looks all good. To be able to securely connect to the EC2 instance using SSH, you need to use a key pair. A key pair consists of a public key that AWS stores, and a private key file you keep for the secure connection. You can use an existing key pair or create a new pair. We name this key pair as web server. The private key file is going to be called webserver.pem. Download this file and store it securely. Let's launch the instance. We've successfully created an EC2 instance. We can go to the instance page and have a look. The instance is launching now. It's showing pending for the instance state. When you launch the instance, it may take 1 to 2 minutes for instance to be ready. We can refresh the list. The instance is up and running. We've added a tag with key equal name and value equal to Cloudemy web server. It's showing as the instance name here. We can remove this tag. The instance name will be removed as well. If you see the instance name is empty, you can simply add the tag. Tagging is a great way to manage AWS resources. You can view the instance details under the instance list. When you create the EC2 instance, you are assigned with a private DNS and private IP address, and a public DNS and public IP address. The private IP address is always associated with the instance until it's terminated. However, the public IP is disassociated with the instance when the instance stops. A new public IP will be assigned to the instance after the reboot. Let's stop the instance. You can see the private IP address is still available. However, both public DNS and public IP are no longer available. After we restart the instance, a new public IP is assigned to the instance. The private IP is still the same. We can go to the status checks. As you can see, the instance has passed 2 status checks, system reachability and instance reachability. By default, EC2 Instance uses basic CloudWatch monitoring. It sends the metrics, such as CPU, disk reads and writes, network, and status check, to CloudWatch every 5 minutes. Congratulations, we've successfully created the first EC2 instance. Please take a moment to review the steps we've done, and try to create another instance on your own. You can remotely connect to the EC2 instance from the local computer. For Mac and Linux users, use SSH client to securely connect the EC2 instance from the terminal. Search for Terminal, you can find the Terminal app. For Windows users, you can use OpenSSH client or PuTTY to securely connect the EC2 instance. We recommend you to use OpenSSH from command prompt. By default, OpenSSH is enabled in Windows 10. You can also install OpenSSH if you use earlier versions of Windows. Click Start and search for CMD, you can find the command prompt. SSH stands for Secure Shell. It's a secure network protocol for accessing the remote server over an unsecured network. Here are the steps for the SSH connection. You need the private key generated from the EC2 key pair for the SSH connection. Open the terminal or CMD, run the following command. Change the permission of the private key to not publicly accessible. Connect to EC2 instance with its public DNS using SSH. First, let's go back to the AWS console. Select the EC2 instance and click the Connect button. This dialog shows you different options and instructions to connect to EC2 instance. You can use an SSH client on your local computer or connect using Session Manager, or you can use browser-based SSH connection. We're gonna connect using SSH client from the terminal on the local computer. Open up a terminal window. First, we're gonna locate the private key. It was downloaded to the Downloads directory. CD to the Downloads directory. ls to show a list of files in this directory. The private key file is called webserver.pem. We're gonna change the permission of the private key, so it's not publicly accessible. Otherwise, SSH won't work. Now let's connect to the EC2 instance using SSH command. When you connect to a new remote host from the local machine, you'll be asked to add the remote host as a known host. Simply type yes to continue. We've successfully connected to the EC2 instance using SSH from terminal. Once we've connected to the EC2 instance, we're gonna install a web server and create a web page using the following commands. Please take a moment and look at these commands. Please note that some commands are different if you're running different versions of Amazon Linux. We've launched the EC2 instance from Amazon Linux 2 AMI. So we're gonna use commands for Amazon Linux 2. First, let's clear the screen. We're gonna sudo su to switch to the super user on this instance. We need the super user's permission to run all the commands. Next, run the yum update command to update the necessary software and security packages. This might take a while if you're updating the system the first time. As a security best practice, you should always keep the EC2 instance up to date. Now, let's run the yum install httpd command to install the Apache web server. We need the web server to host a simple web page. Apache web server is one of the most popular open source web servers. Run the systemctl start command to start the web server. Use systemctl command for Amazon Linux 2. If you're on Amazon Linux 1, use service start command. When you stop and restart the EC2 instance, the web server will stop running. We want the web server to start automatically at each system boot. Run the systemctl enable command to enable automatic service start for Amazon Linux 2. Use check config command if you're on Amazon Linux 1. We're gonna create an index.html file as a simple web page in the web server directory. The echo command will write hello world to the HTML file. The EC2 metadata is the host information about the instance, such as host name, events, and security groups. You can retrieve EC2 metadata from the EC2 instance using a fixed URL. Run the curl command to retrieve the public host name and display it on the web page. We've successfully installed a web server and created a simple web page. Now, let's have a look at the web page. Go back to the AWS console and copy the public DNS of the EC2 instance. Open up a web browser and go to our web page. Congrats, our first Hello World website is up and running. It's also displaying the host information retrieved from EC2 metadata. Now you know how to connect to the EC2 instance and manually run commands to perform certain tasks, such as updating the system, installing web servers. However, manually running commands is not the best way to set up the EC2 instance if you want to launch multiple servers, or if you have many commands to run. You can use EC2 User Data to configure the instance to automatically run scripts during launch. You can put multiple commands onto the user data script. The EC2 instance will run these commands. If you launch more than one instance, the user data is available to all instances in that reservation. Here is the sample user data script we're going to use to launch another EC2 instance. It's gonna update the system, install a web server, and create a web page automatically for us. Let's go back to AWS console and launch another EC2 instance. You should be familiar with all the steps. Click the Launch Instance button. We're gonna keep the same AMI, instance type, and instance details. Except for this time, we're gonna configure the user data script. Go to the Advanced Details, copy and paste the script onto the user data field. The script begins with the # mark to tell the kernel to run the script. It's going to update the system, install the web server, and create a web page automatically during launch. We're gonna keep the same settings for the storage. For tags, we're gonna call it Cloudemy Web Server 2. Previously, we've created a security group. We're gonna use the existing security group. We're gonna set the same key pair for the new instance. We've successfully launched a new EC2 instance with user data. It may take longer to initialize the instance this time, as it's running the script on the background. Updating the system and installing the web server can take some time. The EC2 instance has completed the initialization and passed the status checks. Let's grab its public DNS and check the new website. Hopefully, the instance has installed the web server and created the web page for us. Hello world again, the new website is up and running. This time we let the EC2 instance do the work for us. User data is a much better way to run commands and perform certain tasks. Before we wrap up this lab, let's terminate the EC2 instances we've created, as we no longer need them. Make sure you don't have any unused resources running. It's a good practice to optimize your AWS costs. Here is a challenge for you. Remember the Super Kitty Piano website we've shown you earlier? You can go to superkittypiano.com and join the project. You can even customize the website and see if you can make some improvements. Try to deploy it onto AWS EC2 using user data. Teach your cats to play the Super Kitty Piano, and join the #SuperKittyPiano challenge on social media. Let me know if you can guess what song our super cat was playing. In this episode, we've launched an EC2 instance. We've connected to the EC2 instance remotely using SSH. We've installed a web server and created a simple web page by running commands manually. Finally, we've configured EC2 instance to run commands automatically at launch using user data and shell scripts. Okay, that's all for EC2 Intro Lab. Thanks for watching and see you in the next episode. Hope you've enjoyed watching this episode. If you liked the video, please help us and hit the like button. If you want to watch more tutorials, please subscribe to the Cloudemy TV channel. Make sure to turn on the notification and stay tuned. At Cloudemy, we're passionate about cloud and AI technology. Please share your feedback and thoughts in the comments below. Feel free to let us know what topics you'd like to watch. Happy watching and happy learning.